Okay, on this next video, we're going to be talking about 8.PS4.2, and that is this one where we're going to compare and contrast mechanical waves and electromagnetic waves based on refraction, reflection, transmission, absorption, and their behavior through a vacuum and or various media. What we're going to do, since it's kind of a longer standard, we are going to just take down each term as we go, and we will break those down, and hopefully that will help with your understanding. Once again, this is a review. We've gone over most of these terms throughout the year, and I definitely want you to be able to refer back to this video if you need to when you're completing your assignments. Okay, first of all, let's talk about the terms compare and contrast, and these are commonly misused. But right here, just a quick little Google search ended up with this definition. Compare and contrast are words that are often used to talk about the similarities and differences between two things or objects. These two words are very commonly used. Compare means to see the similarity, and contrast means to see the difference. And a lot of times, I know in class, and you probably remember, we would say, compare to individuals, and a lot of times you would give me actually ways that they were different, and that's not how they're supposed to be used. Compare is showing how things are alike, and contrasting are how they're different. You might say, well, this girl has blonde hair and this girl has dark hair. That's not a comparison, that is a contrast. So you really need to keep those two terms um, differentiated within your mind so you understand the difference between the two. Okay, the next two things that we are going to compare and contrast, or to see how they are alike or how they are different, are mechanical waves and electromagnetic waves. So let's look at the definitions of each. Mechanical waves are waves that require a medium to travel. In other words, they're going to have to use particles to be able to travel. That means, like in air, the particles are farther apart, and so the waves will travel along those. And then obviously on the other extreme, going through a solid, the particles are very close together, so the waves are going to be able to travel faster through a more denser material. The electromagnetic wave, on the other hand, is a transverse wave that involves the transfer of electric and magnetic energy. It's made of vibrating electric and magnetic fields that move through space or some medium at the speed of light. The movement of charged particles creates an electric field, which creates a magnetic field, and vice versa. The two fields move at right angles to each other. And down here it says these waves do not require a medium to travel through. This is why they can travel through space, which is a vacuum. And I want you to think about this. They do not require a medium. That doesn't mean that they can't travel through a medium. In other words, they can. They could travel through water. They could travel through the air, and that's just fine. But they also have the ability to travel through empty space, which is a vacuum. So if we look at the comparisons, how are they alike? Well, they're both transferring energy. We know that's a similarity, and they both can travel through a medium, and that's a similarity. The mechanical waves can be either transverse waves, longitudinal waves, or surface waves, but the electromagnetic wave is a transverse wave. It is not longitudinal or surface wave, and these travel at the speed of light. So how are they alike? They're alike in the fact that they both can be transverse waves, but one of the contrasting parts or the differences would be the fact that um, they are not longitudinal. Mechanical or longitudinal and surface waves as well, and electromagnetic waves are not. And that's a pretty quick comparison and contrast of those two terms. Okay, two terms we're going to talk about are reflection and refraction. So let's look at those definitions. Reflection is when a wave hits a surface and any part of the wave that cannot pass through the surface bounces back. The law of reflection states the angle of incidence equals the angle of reflection, and then we're going to skip the draw and labels section of this. And then refraction is the bending of a wave due to a change in speed. This is because waves travel in a straight line except when they meet a new medium at an angle. One side of the wave will change speed before the other does, and this is what we see. But this is with the mechanical waves, because why? Yes, it's because they are traveling through a medium. So you're going to have refraction that's going to occur when it hits a medium. And if you remember the electromagnetic waves, if they're traveling through a medium, yes, they can refract, but they also can travel through empty space. And so in that situation, there would not be refraction. But once it hits so that's going to be a contrast. But when it hits a medium, it will act the same way, and they are both transverse waves. Also, reflection are those things that can compare or be alike. And yes, they both can reflect. That's why we see, you can see a reflection of a light, or you can see a reflection of a wave that's bouncing off of a rock, for instance, in the ocean. So there are some comparisons. The main contrast being when an electromagnetic wave is traveling through a vacuum. The next term is transmission. And in our situation, we're going to talk about transmission of light. And that's the moving of electromagnetic waves through a material. This transmission can be reduced or stopped, meaning it can be slowed down or stopped when light is reflected off of a surface or absorbed by the molecules in that material. And that's going to lead us to absorption, which we will just talk about now. I think a lot of you have either felt or heard that if you wear dark colors like black in the summertime, you're going to be a lot hotter than if you had on something that was white, because white is going to reflect more of actually all of the light that is coming to it, and that's why we see what we call white. But the black or the dark material is going to absorb those light waves, and they are not going to reflect back. And that's what we see as being black. And so you have the reflection and the absorption, and you notice that some particular mediums through which it travels will either slow it down or stop it. So when it's talking about transmission in this standard, we're going to look at it as light waves, and that is electromagnetic waves. So in that situation, that's going to be a contrast from the mechanical waves. How would they compare? You could have the transmission of sound waves, which are mechanical waves because they require a medium, and those are mechanical waves. And so they can be slowed down depending on the material they're going through. As we know that sound waves travel faster through solids than they do through liquids, and sound travels faster through liquids than it even does through the atmosphere. And that's because the particles are farther apart in the atmosphere. And so they can be reduced or stopped. So transmission is capable in that situation. So that would be how they are alike. And those are just some very, very brief examples of that. Okay, so let's look back at the standard one more time. We wanted to compare and contrast, or to see how they are alike or different, the mechanical waves and the electromagnetic waves based on refraction, reflection, transmission, absorption, and their behavior through a vacuum and or various media. And quite frankly, the biggest difference or the biggest contrast is that electromagnetic waves can travel through a vacuum. But when they travel through a medium like the mechanical waves do, they act the same in those situations. They still reflect, they still refract or bend uh, due to a change in speed when they're going through a different medium. So as far as that is concerned, that's how they are going to be alike. So the main thing that we need to keep in mind on this particular standard for what you're going to need to know at this particular level is that the biggest contrast is that electromagnetic waves will act differently because they can travel through the vacuum or space as we know it. And mechanical waves require a medium, and electromagnetic waves can travel through a medium. So that's one way that they would compare or be alike. Now, I know this was just a quick review, and you can go back over some of the other videos, and I hope you do. I hope this will help you on the questions that you're doing in your assignments. And once again, anytime you have questions, definitely feel free to contact us, and we will be glad to answer the questions you have because you always have great questions. Once again, we miss you, and we hope you're staying safe, and we will see you next time. Bye bye.